Hello, everyone. Thanks for joining. We have Jesse and Daza with us this evening, and we're here to discuss the results for Little Tensas Bayou Experiment, show some photography from the Little Tensas Bayou Experiment, and also the day after, which was the Causeway. And I am hearing myself talking, so give me 1 second. There we go. And so, Jesse, do you want to start off?
Yeah, let me share my screen and I'll show you the PowerPoint. Let's see here. Share.
Make sure you're presented. All right.
Do you see that?
Yes, you are presented.
All right, good. So yeah, I have a PowerPoint I'll go through and talk about some of the results anyway. I know we plan to do several more of these, so I'll jump right in and get started here. There we go. There's the results. The end. No, just kidding. I figured I'd just jump right in and get right to the meat of it, what people are interested in seeing, the actual positions of the lanterns that we hung on the
And Jesse,
columns.
maybe we should give them an overview of what we did that day, the work day.
Oh, that's what's going to happen right after this.
All right.
The next slides go into some of what, how we arrive at these results. But I figured I'd start right here and let people make a screenshot of that if they care to. A point name. These are my control points. These are the lanterns, L0 through 7. Latitude and the positional tolerance column on the latitudes. Longitude, positional tolerance, and these are reported at 95% confidence. And then we have the elevations and within 2-inch type tolerances that we were setting out to achieve, which that's what happened. We did good. And here's just the column of the descriptions. I'll just move on from here. We could drop back to this if people have more questions on that. Showing the layout. There's L0, lantern a mile, and proceeding up through toward, I won't say Rama, I'm going to say Rama, mile 7. And here's a shot of the control points on the west side and east side. The next slide shows you the first benchmark stake that was set at the level, or at the water surface level on Friday. And unfortunately, we tried this a little earlier. I have video clips here, but we can't play them because you will not hear the sound. And I felt the sound was some of the exciting parts. So I may choose to upload those in separately, but yeah, go ahead. You were going to say?
But basically, for the crowd here, you're hammering in the stake into the water, and you're stopping right at when the top of the stake hits the top of the water.
Correct.
And you're setting that as just a baseline for where the water level is.
Correct. So that we have something to put a survey rod onto and measure from the water level. You can't hold a rod on the water, so you put a stake stopping right at the level of the water. So this is a picture of what's happening on Friday, and here's a picture of doing the same thing within probably 40 minutes. I was very attentive to set these very close together in time. So I set the one and did nothing else there, jumped in the vehicle, drove across, and got the one set on the west side. And so that's what we have. Now, the next day, and of course, on this day, it was snowing and raining periodically throughout the day. So there was a lot of precipitation buildup. And the very next day, I was curious to know what happened, and I went over to both stakes and measured and recorded these pictures in water due to the precipitation. And there it is. We have 35/100ths of a foot side and about 3/10ths of a foot on the right, on the east side. And I'm making a note here that we measured these in the morning and in the afternoon, and the readings were the same. And I have those pictures as well.
And this is a point of confusion for me. Those are tenth of foot markers,
correct,
instead of inches, right?
That's right.
Yeah. So that's
point 0.5 would be 6 inches. Yeah.
Right.
0.3 is 4 inches.
Yeah.
Okay. So moving. So here I just included a screenshot of publicly available tide gauge information. And it indicates that this area is not tidal, but it certainly does fluctuate with precipitation. And we certainly noticed that ourselves. So if and when there was some need to gain additional precision in what we did, we have the recorded times of those pictures. We could do some interpolation, but I don't see a need to at this point anyway.
That's because at the end of the day we remeasured, right, Jesse?
Correct. That's right. We measured first thing Saturday morning. We hung the lanterns, and before observations took place that night, I have pictures of those measurements again on those stakes.
And was there a change?
It's the same. That's what I was saying here. They remain the same. 3/10ths here, 35 there. And exciting video in the presentation, but I can't show it to you right now. But we began hanging lanterns using this boat from your uncle, which was awesome. Really done. There's a rainbow right here. That's a cool picture. Basically came up to each column at mile spacings and used the rope or the straps that we used to hang the lanterns, got ourselves around there and put the lanterns up. We could easily measure 5 feet. A total of 8 lanterns. These are all 5 feet above the water.
The center of the lantern light, like the white area, is at 5 feet. That's what we did.
Here's a close shot.
Yep.
So, these lanterns, to be about 3 inches, when you're up close to them, but they look like pins or stars, miles away. So they really worked out well, soundly. These lanterns you chose were perfect.
Yeah, I was really worried about them being bright enough, but they did. They ended up doing their job.
They were terrific. So here's L0, and you can see how close we are to the shore there.
Yeah, and the reason we didn't put it on that first pylon is because that first pylon is actually angled. There are some...
They call that a battered pile. Yep. Yeah. It's angled away from us, basically. Yeah. It's tilted. And no, I think the way we spaced them out, we were looking for not, 5,280.00 feet. We were looking for a mile. And,
we're within to it.
That kind of tolerance. So then night fell and we're ready to get going here. The first occupation was on the west side on my stake number 2. And what we did was set the theodolite at 5 feet above the water surface. And so there's a picture with the flash. T2 theodolite, which illuminates my ability to read the horizontal and vertical circles at night. What I want to do here is just make mention that we're not doing anything unique or out of the ordinary. It's these procedures up. This is just geodetic triangulation. Same methods and procedures used to produce all these triangulation diagrams throughout the world. Here's one. Here's RAMA. This is the old scheme performed to establish control, geodetic control points, graphic maps, and the old books. You can look up lots and lots of these old references about how maps were made. Example of an old map from the 50s. In fact, Route 10 isn't even here. It's in railroad track at that point in time. And the reason I'm mentioning this right now is because we do hear criticism or the surveying that we're doing as part of this effort to show people that the Earth is curved somehow is flawed, or has the instrument is flawed, or the lens is creating anomalies, and on and on. You hear a lot of these excuses, but we have all these maps. We have all the mountain heights. The elevations of the mountains are determined by triangulation. Which is it? We either accept that we can measure and we can position things in 3 dimensions using surveying methodology, or we can't. So if I'll just leave it there. I hope you get my point there. That's what we're going to do. Is we're going to triangulate to establish the positions of the lanterns, and the elevations are determined by the measure up using the water level surface as an instrument, essentially. Just that gives us the elevation of the lantern. The thing that remains to be done is to position and determine the elevation of the stakes so that we know what the elevation is of the water. And that's what we did during this survey. At L0, which you could see is very close by, and the telescope is set to 90, and I'm not sure if you can see it, but there's the crosshair going right through the lantern. So the theodolite is set at 5 feet above the water. The lanterns are set at 5 feet above the water. Okay, this is a very interesting picture here. I swing the theodolite outward, mile, L1, L2, and L3. And just repeating this, that the telescope is set at the same height above the water as the lanterns. And so,
just a reminder too, that L0 is the actual first lantern. That's our 0 mile. So you're looking at mile 1, 2, and 3 lanterns right here.
Correct. L0 is out of view toward the left, and this is the telescope swung toward the right, looking out down through the bayou here. Now,
right. So these are 1 mile apart. These lanterns.
That's correct.
Okay,
yes.
Just an observation there. You notice how we're seeing the compression already of the image. If you look at the distance between L1 and L2 compared to L2 and L3, and later on, Soundly, when we look at your images of the bridge, that's a point that I think that people really need to take on, is about the compression of the distance in the image.
Right.
What I also want to show you, this could be debatable. We're looking here that is this lantern truly lower than the crosshair? I think it is, and maybe someone who has the ability to measure pixels could determine who that is. There's no doubt about it that L2 dropping below the telescope crosshair. L3, it is. It's lower than the horizontal crosshair. L4 through 7 are not visible from this setup, and I can't tell you exactly why.
I think we have an idea why.
Okay. 4 is debatable. Maybe it's blocked by something, but I doubt it. But the video that goes with this, and at some point maybe we'll cobble together a real video and beyond doing a hangout like this. But at least people are at least getting to see right now, 1 week later, what we were able to produce over here. Okay, moving on. What I'm going to show you next is measurement. All right, so we have the photograph, and I just want to mention one more thing. Survey practice, we would not take a 1 second theodolite, set it to 90, and expect to 3 miles away. I've only done this as a visual aid for people to take a look and see this visually. Advantage to this type of theodolite is to be able to measure these angles with very high precision and very good repeatability. Showing you one table of some of our measurements, and that is just occupying Little Tensas Bayou point 2 is being occupied, and these observations are to these lanterns L0 through 3.
And Jesse, for the layman, occupied means that's just where you're shooting from, right?
That's correct. The instrument is set up over that point, and it's actually set over stake 2 at this. And I'll show this subsequently in later times. Why is it 487? Well, because the stake is out of the water, and we know the difference between the water surface and that stake height. So it is 5 feet above the water. Okay. So basically, it's from to, or HI of the instrument, height of instrument. This is the 2 point. This is the height of that point, and 0 here because we're aiming directly at the object rather than a target or something set over something else. So it's right to the lantern. These are the horizontal directions. We're not really concerned with those at this point. Just the averages of 2 sets. And the yellow is the averaged result of the zenith angle. That's the vertical angle. And what I'm showing you here is what is the expectation, or what is the predicted, using this formula. This is a calculation, not a measurement. It's using 0.57 feet squared. And you'll notice, everyone is using 8 inches times the miles squared, which is adequate for rough approximation. Here we're trying to get a little more precision. And so 8 inches equals 0.67 feet.
Say that again, Jesse. You broke up a little bit.
All right, starting again, I'll tell you that 8 inches equals 0.67 feet. Of 0.57 accounts for refraction, standard refraction. All right, so it's another estimation of refraction and curvature. So let's look at those numbers. This is what we expect in that first mile, and this is what was measured, 0.46 trigonometry. That would be the cosine of the zenith angle times the distance in feet. And the difference between the two to 1 part in 48,000. Surveyors will recognize this type of terminology where we compare to what we measure, a precision statement. Here in 2 miles, 2.28 feet is the expected drop. The measurement was 2.12 using that zenith angle. And here we have a precision of 1 part in 66,000. And the last one at 3 miles, we would expect 5.13 feet, 0.26. It's 1 part in 122,000. So we have fairly good precision between what we measure and what we calculated as to be the predicted amount of the drop from the horizontal plane.
So it sounds like this is telling us that the lanterns are actually dropping below the horizontal plane.
Without a doubt. Just measuring to the close by lantern, we're at 90. If someone wants to squabble about 2 seconds or 3 seconds within 90, there it is. And so there's no drop. Go a mile, and there it is.
Nice.
These are definitely, and then I've only included this in this hangout. I've only included these measurements. We certainly have measurements from all the other control points, and I think I'll just continue to produce to show what it looks like at 4 miles and 5 miles, etc. From the higher point here. At this point down near the water, 5 feet above the water, I could only get these. The point L4, or LT, Little Tensas Bayou 4, is up above me, 17. and I could see a lot more of the lanterns. Still couldn't see the last one though. But anyway, I'm digressing there. That'll be for another presentation. But the angles continue to from the horizontal. And at the close of each day and throughout the day, I definitely tried to stay in touch with my Facebook group and my channel, giving little updates, and people were happy to see that. And got a lot of nice comments from people saying, stay warm and all that. It was cold. We drove up there Friday morning in a snowstorm. I didn't expect that in Louisiana, but that's what we had.
Very odd weather.
Yeah, and so here we are. This was Saturday night, and I have to tell everyone, Sally and I, we shook hands Saturday morning. We jumped in the boat. We hung the lanterns, and we hardly saw each other after that. He went his way, I went mine, and he was all over the place. Doing the photography and the videoing. I was just out there doing the measuring.
Yeah, I would say that we quite intentionally worked together to hang the lanterns and get all that work done. But then we both had our own mission. We both had our own course of action, and so after the lanterns were hung, I went and did my photography, and Jesse went and did his work, and at the end of the day, we came back and discussed results. But until today, really, we haven't aggregated all the results together. So, and it's interesting to see how our separate. Go ahead, Jesse.
Yeah, I was just saying, and there's more to look at. I mean, there's a lot of data that haven't had a chance to boil down yet, but we'll get to it.
Yeah.
Well, this is a good handoff point. I would be going on into Lake Pontchartrain at this point. How about if I hand it over to you?
All right. Yeah. So I'm just going to share the photography of the day, and well, I guess we did discuss the work that we did hanging the lanterns. But I wanted to mention something. The time lapse that I put out actually shows, if you pay attention, you can see a boat that's always on the zooming from one pylon to the next, but always on the right side of that time lapse. And unfortunately, I didn't have the time to put the visual together, but maybe somebody else will do it for us. If you actually map that boat, which is sitting on the surface of the water, that boat's path makes an arc from pylon to pylon.
Sounds like a tall story. So, I think you'll have to show us that.
Yes, I will have to put it together, I guess. Of course.
I'll stop sharing
I'm
here.
I'm not the best at that type of stuff. What's that?
I stopped sharing, so you should.
Okay, yeah, let me pick it up here. Okay, so I'll be sharing the photography. I wanted to show this one first because this has been a point of contention among flat earthers for sure. There was definitely some refraction going on early in the evening after the sunset, and this is the case of the worst frame, essentially. That's showing that the lanterns are actually curving up right here. And if anybody hasn't seen the time lapse, they should go watch it because it's essentially an entire day, and I'll show it here in a second. An entire day of curvature. You can see the curve. Yes.
Sounds like you're not sharing your screen at the moment.
Oh, I'm not. No. Yeah, I have to present myself. That would be a good thing to do. So let me go back here. And I am sharing my screen, but I'm not presenting. Is that correct?
I'm not seeing your screen on the live feed either. Okay, seeing it on our feed. I'll just check the public feed. And there is a delay of several seconds, so we'll just make sure that everyone can see that. And there it is in the public feed. Yep, go ahead.
Okay, great. So going back to what I was saying, there was definitely some refraction going on. This is definitely the worst frame that I could find, which happened at 1807. This was maybe an hour after sunset, a little bit over an hour after sunset, probably. And there was definitely a period of time where the atmosphere was playing tricks on us, and it was the lights were waving up and down. I put this out there. I put the time lapse out there for the sake of transparency, and I knew that there was going to be some pushback from the flat earthers. But the one thing that I noticed, and that I knew they would not notice because they would cherry pick the data, is that the reflection is wrong. And the reflection is wrong on every image if it were a flat surface.
Mm-hmm.
And that's something that you can point out in any image that I've ever taken of this area. These are some of the better images here at the end. But to do a really quick version of the time lapse, here it is. You can see it waving down there at the end. There it is. And but here's what the day looked like right here. And the bridge is obviously curving. And if you go to the end of the time lapse, you can see that the atmosphere starts calming down, and you're definitely seeing the curve there. One thing to point out is that these two lights are also our lights. They're my lights that I set up. One is sitting on top of a ladder at the top of the boat ramp, and this one is actually blinking, which you can't tell in the time lapse. There's some videos that I have of that. And so those also move up and down. And you can see that they're moving up and down. So it's very interesting footage for anybody who wants to go take a look. Let's move on. So this goes to my other point. You know, when you have a flat surface, you expect to see a perfect reflection. You know, this is pretty close to a flat surface since it's a very short distance that I'm looking at here. And this is underneath the Little Tensas Bayou Bridge. And so this is what you would expect to see, right? Almost perfect reflection. But in reality, you don't see that. So this is the same Little Tensas Bayou Bridge, but now at a larger focal length. And look at this reflection right here. That is not the reflection of a flat surface. That is the reflection of a curved surface. So some of the better shots of the evening were actually overexposed. This was definitely a very hard area to take photographs of because I was dealing with, I was trying to basically get multiple exposures going. I wanted to be able to see the bridge, not just the lights. Auto wasn't going to work because it always tried to auto meter off of these cars. And we're trying to take pictures down in this very dark area. Even this reflection of the cars was problematic for the automatic modes. So I had to take some manual shots, but I was able to get some good ones. That one's a pretty decent shot right there. And we were definitely fighting the atmosphere. You can see that it's not perfectly clear. You can see that it's actually overexposed. I mean, this lamp, which is further away, is about the same size as this lamp here. And that's just because it's overexposed. But I had to overexpose it in order to get any of the bridge.
This is so interesting, Soundly. I'd like to just mention that I get a lot of comments about, and people want to know what kind of zoom it has, and you know, they'll see pictures and they'll say, "Oh man, you need to zoom in further." They don't understand that the telescope of a theodolite is very similar to like a rifle telescope. Meant zooming in close.
Your telescope.
And these.
I was actually impressed with the theodolite. I mean, it actually has some pretty nice magnification on it.
Yeah.
It does, but it's
adequate for the job, and it only has one job, and that is to point that crosshair on an illuminated target in the night or in the day. You have to have you have to have the resolution to be able to see what you're aiming at and point on it repeatably. These lanterns looked like stars to me. They were very sharp, you know.
Mm-hmm. And I do have some pictures where I underexpose them intentionally.
Okay.
Which apparently I didn't add to this slideshow, but I will be happy to provide them to whoever would like to look at them. I think they make
these
a
look
lot
like
of sense, but
you overexposed. Is that why they're?
yeah, the problem is that I mean the reason that this lamp at the end looks as big as the lamp in the beginning here is because this picture is overexposed. And I overexposed it intentionally in order to get the features of the bridge.
Okay.
To try and see the features of the bridge, and I have some that are underexposed, so you can actually see just the lamps as pinpricks, but you can't see anything else except for the lamps.
Okay.
So it was a very hard. It's a very hard area to photograph. I can tell you that it was much easier to photograph the Causeway and the Marriott and stuff like that.
I'm smiling
But
right
this,
now because you know, as coming or even before twilight, but just we got set up and we're like, oh my God, are we going to see these? And as night,
yeah,
they were like, you know, just shining out there.
yeah, yeah. I was actually relieved once I finally saw them in the night, but because at first I was very worried about it. I was like, wow, are we going to be able to see this? But we were able to see it. I meant to actually add a picture, and you know what I'm going to do? I'm actually going to show this picture because I think it's important to see.
Okay.
I'm going to come back over here to a screen share, and we'll stop screen sharing for a second so I can find this picture. But I did take a picture from.
I'll just say,
I did take a picture.
You've got a box of you have a box of lanterns now. What are you going to do with it?
I know I have 8 lanterns and nothing to do with them. I'm not sure what I'm going to do.
I'll take 2 or 3 of them, but I think we should ship them to anybody who wants to on some other body of water anywhere. You know, as long as it's long enough, 5 or 6 miles.
So I was actually thinking about doing this on the Causeway. Like I was actually thinking about maybe having, because I actually think that me and my uncle could do this, but since we were able to hang one lantern, just the 2 of us. I think we could probably do it. We could hang lanterns on the Causeway. And I was thinking about doing that.
You'll need much larger straps. Those pilings are tremendously large, aren't they? They're a lot bigger than this road, aren't they?
I don't think so. I think they're about the same.
Okay. I didn't.
Maybe not. Maybe not. I don't know. I'd have to go look at them again. I'm not sharing my screen right now, right? Correct?
Correct.
Okay, good. All right, let me find this picture real quick so that I swear I had opened it. I had this one open, so I'm not sure what happened to it. Let me find it. So there is a levee on the Rama side, and I went to the bottom of the levee and took pictures from the bottom of the levee.
That's about where my stake 3 is, right? You mean along that road?
Where you had the GPS receiver right at the very end of the, like past the dam on the dirt road?
Yeah.
You had that, yeah, right. You had that at first?
That's basically where I took the picture of you in my group.
Yes, yeah. So that picture that I was taking is actually one of these. It's probably this one. So let me go back to screen sharing here. So I actually opened up one of the other ones where I underexposed it as well. Okay, so screen sharing. Thanks for hanging with me, guys. All right, so this is from the bottom of the levee, and this is L7. So this is the last lamp. No, this is L6. L6. The last lamp is actually out of frame. So this is 6, 5, 4, 3. A whole bunch of missing lanterns. 2, 1, and 0 are missing in this picture. And that light that I told you that was at the top of the boat ramp, look at it right here. So this is the water level right here. You can see it being mirrored in the water. So there you go. Lamps are definitely missing the lower down you go, as predicted.
That's interesting, because listen, your camera is down. You're like down on the ground, right? through my field.
Yeah, but remember, I'm on that roadway, which is just slightly above the water, so it's not exactly to zero, you know.
No, but what I mean is you're down on the ground at point, and my tripod, when I observed from there, I'm higher than your camera.
Yeah.
And I could see, and of course it's close.
Soundly, can you present to everyone, please?
Oh, thank you, Daza. Sorry.
Oh, sorry about that.
Forgetting that part of it.
Anyway,
do I need to go? I need to go back and talk about that again, I guess, huh? Or did anybody see it?
It was sharing.
Yeah,
it's just that if you don't present to everyone, then if either
it's
Jesse
only when
or I talk, then it switches over.
Yeah. Okay. So I assume everybody saw this picture then, but there it is again. That's the 4 lamps. That's L6 on the right. 5 and 4, 3. 3 is the last lamp you can see here. Again, this is at the top of the boat ramp on the other side where you can clearly see the water lines about right here. And there we have 3 lamps missing.
Right.
From that lower level.
Do we need to just be very clear here about why they are missing? It's not because the experiment is screwed up. They're missing because they're hidden over the curvature of the Earth.
That's correct.
Yeah.
I concur. And, you know, I look here and I'm looking. I was set up next to you, and that's as far as I could see. L3 was the last lamp I could see.
You were slightly higher than me. Yeah. You're slightly higher than me or lower than me?
I was slightly higher because your camera and telescope. Remember that picture I have of you? You're crouched down, so you're you're next to the ground,
right?
And my theodolite is set up, at about 5 feet above the ground, but I could only see as far as you did. Also, L3 is as far as I could see.
Yep. This is what you were talking about earlier, Jesse.
Yeah. Yep, there you go.
This little void right here. So there's actually a crossover halfway out, and that crossover was blocking the lamp, but it wasn't blocking the reflection of the lamp. So what we're seeing here, this is a little bit less exposure. You can see that the lamps are actually getting smaller and curving.
Nice.
So,
and once again, just to reiterate, these lanterns are 1 mile apart each one.
That's correct.
Yes.
1 mile apart. So you can definitely see the compression due to perspective right here. There it is. And I think, Jesse, you're up.
Okay.
If I remember correctly.
Yeah,
let me see here. Yeah, now we're on the causeway. So
you want to go back to? We'll be going over to Lake Pontchartrain next.
Yes.
Okay. So you're giving it back.
Oh, sorry about that. Hold on. Let me.
So I'll hit share. Share.
Yeah, if somebody could stop my presentation for a second, that would be good. I don't want to have to actually show people stuff.
Is
okay, there.
Up?
Yep.
Hello. Do you see my screen?
Yep, you're up. I got you presented. You're ready to go.
Okay, so you see that?
Yep.
Okay. So again, this is December the 10th. I'm going to show you the triangulation that we performed to position the Marriott for horizontal and to get the elevation of the roof line and the red lights up top. And as before, I'll just jump right in and just show you those results. And after this screen, I'll show you the methodology. Just as before, it's just a column of the points. These are my control points, LP for Lake Pontchartrain 1 through 4. M1 through 6 are the roof corner, 3 red lights that I could see, and 2 more corners. These are the elevations. I didn't mention this before, but when you talk about elevation is in reference to some, and in this case, I'm using the North American vertical datum of 88. That's 1988, and that is the current vertical datum in the United States. And that's it. So you have latitudes and the positional tolerances on those. You notice right away that these are much tighter positional tolerances. The reason for that is that we had better geometry, as you're going to see in the pictures, from where we were to be able to triangulate the building. I have to say that back at Little Tensas Bayou, you have a very narrow corridor. The geometry caused, it is not conducive to doing triangulation. If I was to do this over again, I think I would stop being so kind and using a manual theodolite and actually use an electronic total station so I could measure the distances, and I would have had higher precisions on the horizontal component. But it didn't matter anyway because we were really interested in the elevations, and so we have that. But I just thought I'd mention, you could see we have a much tighter positional tolerance in this campaign that we did over here. So here's Lake Pontchartrain, here's the Marriott, and here are the points that I set to triangulate that. I'll show you a close-up of those. And then on the other side, I have 2 points established that we use to measure across. And let's look at that. So here's my baseline, 1 and 2, over at this, I guess this is a ship entrance. I'm not exactly sure. This is a little park over here.
Can I pause real second, Jesse?
Yeah, go right ahead.
So if you look to the left side of Jesse's screen there, you can see 2 tennis courts. That's actually the Marriott's tennis courts. So
yep.
You can see the red spots that are all Marriott and marked with M everywhere. So just to give people some context, and that's the Causeway.
Yep, there's the Causeway. And so here's the Marriott building, M1 through 6, 2, 3, and 4 are the red lights that I could observe, and M1, 5, and 6 are the building corners. Okay. Of that, I actually stayed in the Marriott. We were on the 15th floor. This building, I understand, is 34 stories. The hotel only goes up to the 16th floor. The rest are offices and other. So if you're going to get a room here, the highest floor you can get is the 16th. So I was on the 15th, right about in the middle here, because we could look out and see the tennis courts. And I mention this now because we have something exciting to show you later. All right, here's a cross on the North Shore, LP 3 and 4. As a baseline to set the theodolite here, backsight this point, and turn angles across. Now, again, as I mentioned before, with Little Tensas Bayou, I just want to remind people that, again, this is not anything unusual, extraordinary, or specific to me, or something I've come up with. No, I'm using standard from long ago. It's called geodetic triangulation. Here's a little snapshot of a control diagram for Louisiana, and every state has one of these, and I have all of them because I like them. And this is showing you the triangulation performed across the lake to build the causeway. All right, so we're using methods that were construction to establish control and do construction set out and layout for building this bridge. Here is the diagram that was used as an example back then, and this is I think this is back in the 50s. You can read this yourself. I just snapshot these 2 messages here on the map and blew them up here. Triangulation was used, and we are using triangulation. These are the same methods. We are producing positioning results. There's nothing wrong with it, is what I'm saying.
Yeah.
Okay. All right.
Geometry.
So here's just some shots of me at my baseline. This is the first point. Here's the Marriott off in the distance. There's here. It was funny to see that sign right near the body of water.
Watch out for alligators.
Snakes. All right. So then here's another shot at the other point. So we had pretty decent geometry to direction and this direction, horizontal and vertical angles. This is just a shot through the telescope showing you the T2 theodolite pointing on that building corner. That's M5. And here's just a snapshot through the telescope showing you one of the red lights up there. This is me just keeping people informed throughout the day of what we were doing. And I think people appreciated that. I got good feedback. And I did that in my Facebook group, Flat Earth Can't Geodesy. And I also did it on my channel, just little 20-second video clips informed. So at this point, the triangulation was finished and we went across for the sunset. It was quite beautiful that night. And Soundly, you were correct. We picked a really great weekend for doing this. The sighting conditions were really fantastic. So it's a beautiful.
Well, I can tell you that I've been there a number of times, and I have never seen the clarity like we saw it that night. I went back a couple nights later, and it was about the same. But and maybe it's a winter thing, but I've never seen it personally that way. So we definitely picked a good night.
Awesome. Okay, here's you and me finally working side by side. So here's your camera set up, your telescope on this concrete slab. And this point over here is just a spike that I set at the corner.
Yeah,
There's
I'd like to point out more. Let me mention more about that spike. That spike, you know its exact GPS coordinates, correct?
I know it's on my chart that I go. It's that is LP_3, latitude, longitude, and elevation.
So for future observations, if I go and put my telescope on that spot, then we'll know exactly where that photograph is taken.
Even if somebody pulls out that spike,
it's at the corner of that concrete
slab. Right there is close enough. Like I said, look at the chart. That's LP3, latitude, longitude, elevation to it's about what 2100ths is about 1700ths is 2 inches, so just a hair over 2 inches. Positional tolerance at 95%. I'll mention what that means. It means if you return to that spot 95 times out of 100, you will be within that tolerance. It doesn't mean it's wrong by this amount. It's just giving you a feel for the precision or really it's the accuracy, but in other words, 100, you'll be within that amount, within this amount, within this amount. You can see the horizontals are quite good. So
gotcha.
To where we were, here we go. So this is us getting situated, getting set up, and this is me just showing you the height of the theodolite above that mark is 4.9899, right about in here, measuring to the center of the horizontal axis of the instrument. This is a pretty spectacular picture for me to see. It's really, that is the telescope set horizontal. I'm giving you my data that I'm 4.98 feet above that elevation of about, what, 7.21. So you could calculate the elevation of the horizontal. And ain't no way that that where I'm looking at that building is what, 5 and 7. That is not elevation 12, right?
No.
So
that is not.
And
which I will be showing a little bit. Go ahead.
Okay. So again, just posting.
I think Daza was saying something.
Oh, go right ahead. Yes.
I was just going to say, Jesse, I'm a little bit concerned about this photo here, looking at the at the hotel there. I hope they pumped all the water out of your hotel room.
Yes.
Can you sort of point on the picture about whereabouts your room would have been?
Well, I'm going to take a guess, okay? And it's unfortunate because the glass was I don't care what you did at the window, people weren't going to see you. It's that kind of glass. And I was excited to think that I could put a target in my window and triangulate its position also. So that didn't happen. And, you know, we would just have to guess which window it was just by counting up. But from this picture, I can't begin to tell you. I just don't know.
You know how there's this 20/20 hindsight that everyone has?
Yeah. We'd have to.
After the fact, I was thinking we should have asked someone to sit in your window or sit in your room and flick the light on and off. We would have been able to find it.
Oh, heck yeah. Yeah. They'd miss all this fun, but yeah, we could have paid someone to do that.
So the neighboring building that we see to the
one
right
of the lanterns from this, but you know.
Jesse?
The neighboring building.
Yes.
Yeah, the neighboring building on the right there, was your room above or below the level of the top of that roof?
That is a good point. I think we were below it. I think that. Oh, okay. You just helped me figure this out. Thank you.
Yeah. How many floors did you say that the Marriott has?
34.
34.
34. Okay.
Yeah, and see that building right there? You can't. Soundly has better.
Yeah.
Building.
Maybe
here.
Come back to that later.
And I'm below that building. My room is down here.
Right.
Because I remember looking out my window, and that building is probably 2 or 3 floors above me. Yeah, something like that. I have a picture of that out.
So just to give people context again, the Marriott is actually in 3 Lakeway. There's a whole complex of buildings there, 3 buildings, and they're called the Lakeway buildings. And the Marriott is in 3 Lakeway, which is the tallest one. There's 2 Lakeway, which is the one you can see on the horizon to the right. And there's 1 Lakeway, which is completely obstructed for the most part. I think you can see just the very tip of one Lakeway. Did I say 3 Lakeway? 1 Lakeway. 1 Lakeway is completely obstructed. Continue.
Yep. Then I'm submerged. I'm down here.
Yeah, you're drowned.
Drowned.
Yeah.
It's a good thing I'm on this side looking back. Okay. Again, I want to make sure everyone understands that this is purely just done for a visual aid. It's not a normal survey procedure to set a theodolite at 90 and then expect to do some kind of work 24 miles away. It's not doable, but it is sufficient to at least show you the drop of the curve down from the horizontal plane. And that's all I'm doing in this picture. The real use of the theodolite is to begin measuring to the lights, and this was us completely done on that side, and I just wanted to make an announcement to the group. We're done with that. Now the next day, I went back the next day and got the auto level out. This is an instrument I encourage people to use because the theodolite can be intimidating. It's got a lot of knobs and dials, and especially the electronic total station instruments, they could be intimidating. You may not feel like you're up to learning how to operate one of these, but anyone can take one of these auto levels. You can buy them very cheaply. I bought this one for just $200. You can rent them at a construction rental place, a Taylor or a Home Depot. You can borrow one from surveyors that you may know. So get yourself an auto level, and it's very simple to set up. It only has a bullseye bubble here, and it has a prismed mirror here so that you could see that the bubble is in alignment. And when you have achieved that, the pendulum takes over the internal compensator and establishes a level surface or a level reference for you. That's what we're looking at here. I posted this in my group, Flat Earth Can't Geodesy, and I want to show you a view of that through a video that I took. This is the video, because I got a lot of questions about, is my level in adjustment and all, et cetera, et cetera. And I made this video to show that the level was absolutely in adjustment. Comparing this to the theodolite, we're looking at the same thing. It's just not night, it is daytime, it's in the morning, and it's hazy, but you could still see the Marriott is there. It's like a little ghost showing up. I'm just drawing a little outline for it. It's there. Horizontal crosshairs striking through the building at about the same height. Again, this isn't perfect surveying. That's not what this is about. This is just showing you what the horizontal, when it's extended out, location. And this plane is perpendicular to the vertical direction at where you are observing from. And I tell people to do this because no one is bothering to establish this type of reference that they're viewing. And we do see a lot of videos about mountains that we see that we shouldn't see. They're so far away, we shouldn't see it, etc. And a lot of these are confusing the 8 inches times the mile squared formula that calculates the drop of the curve from this horizontal surface. Inches times the mile squared calculates that drop of the curve. As you're going to see in a little bit. All right, so 8 inches times the mile squared does not calculate calculating the drop of the curve from the horizontal, and you have to establish this in order to make sense of that formula. I'll pause here and see if any of you guys have anything to add to that.
Jesse, can you just repeat that last statement about what it doesn't calculate? Your audio is dropping out from time to time.
Okay, sorry. That 8 inches times the mile squared does not compute the hidden, calculates the drop of the curve from the horizontal plane that is established perpendicular to your vertical direction at your location.
Right. And there is a lot of confusion over these 2 points within the flat earth community. I have actually got a video on my channel demonstrating the difference using graphics.
Yep, I've shared that in my group, and it's really well done. Good presentation on that. And there needs to be more of that, because I still hear people constantly confused by this.
Well, the thing is that all of these things have been answered before, but the problem is they all come into the same funnel.
Right.
The Dubé funnel, where they have to actually go through that process of hearing the answers for those things before they can actually move on to, I guess, the more modern discussions that are going on. Like I mentioned in my recent video, at some point, every time you looked, the surface of water was flat, and all the lines were straight and nothing was curving. And then as soon as we started providing evidence of ships over the horizon and buildings over the horizon and curving structures, well, then they had to switch gears and say, well, yeah, it appears to be curving, but it appears to be curving because of perspective, which makes no sense. Perspective, exactly.
Well, if people will watch this video, if they watch this video, and I apologize, it's very choppy. It's me holding the phone up to the level instrument, and it's not an easy thing to do. I did order one of those eyepiece adapters. I can't wait till it comes. But this level, I swing the level all the way to the left at the bridge right where I am, and I'm below the bridge, literally below it. As you swing it across, descend below. And of course the huts, I'm below the huts here. This hut crosshair, here's one of the huts. I'm below it, and as you swing out, there's the huts dropping, dropping, dropping. Oh,
and that's really that's really like a Little Tensas Bayou Experiment, just set up for anybody to go and look at. I mean, that's the whole thing that I've been trying to get people to do. Just go out there. Just go out there with your auto level. Go out there with your P900, and you can see this stuff for yourself.
What we need is a P900 with a vertical sensor in it, so that you could set it up. And maybe it's not a P900. Maybe it's some other type of camera that does have this type of, maybe a photogrammetric camera might have this in it. I've never used one, but
well, I was if we could calibrate.
This is the big thing that's missing. Instrument is the cure-all for the flat earthers. It's inexpensive. You can go get one. That telescope.
Right.
That's all I can tell you.
Jesse, let me ask you this: do they have auto levels where you could mount a camera to it? Like you could calibrate another camera to sit on top of the auto level?
Sit on top of it? I don't think so.
Like the base,
but there
the base of the auto level.
Old photogrammetric, photogrammetry today is practiced from the air, looking down. In the old days, before laser scanning that we use today, there was terrestrial photogrammetry, and they literally could mount a camera on the wild T2 theodolite. And we're talking back in the 20s, 30s, 40s.
Nice.
And it was used a lot in plants and in other areas where there was lots of detail that they wanted to pick up and position. This type of equipment is out there, and
I think using that that cell phone adapter with some sort of mounting on the auto level might be one way to do it.
Well, it's on order, and I appreciate you suggesting that to me in the comments of this particular video. And as bad as it is, I mean, you do see me struggling trying to get and remain in eyepiece. But if people can just bear with it, maybe just fast forward through that, you do watch me go all across the lake, and it remains, at this level above the horizon. And that's another thing.
You can
the horizon.
Go ahead, Jesse.
Is to eye level. I mean, why is this like this? Isn't that supposed to go on and on or something? Whatever.
So I'd like to point out that you can see both buildings there.
Yeah, you can. There is. Yeah, he is over here, right? I think I only have two slides left.
Let me interject right here, though. Let me just interject and share my screen for a split second.
All right, you want me to stop sharing here?
So I'm going to do this.
Just remember to present to everyone when you share soundly.
Okay. And I'm looking for a particular. There it is. So this is what Walter sent me, actually. Can you see this?
Yep.
So this is Walter Bislin has this great website. I want to try and push his stuff every chance I can, because he has so many good examples now of different topics that we all talk about in the flat Earth versus, well, reality debate. And this is his, he tried to set up basically in his model. He has a model of the causeway, and he added a model, basically a building. And here's eye level. So he tried to essentially just say, okay, well, if I actually went to that location in my model, what would I see? And this is what he sees.
Soundly, can you drop the link into the chat, both the public and our Hangout chat, please? Sure.
Yeah, I will drop a link to Walter's stuff. He has a bunch of great, just so many things. Causeway, transmission lines. And the causeway is actually an older version. I wish he would change his name, actually. But this is actually the causeway right here, too. The one that's marked soundly. It's just observations that I've made linked to his very nice causeway model. Anyway, I will. This is a topic for another time, but I will be happy to paste the link for everybody to take a look. Go ahead, Jesse.
I was just going to tag onto this that I don't know if it's of any use to Walter, but I have tons of angular observations that I don't know if they would be useful to him in his modeling software that I'd love to hand over to him, of the Philadelphia skyline, of the New York skyline, the Empire State Building.
He would be more than happy to take this. I promise you.
Cape May Lighthouse across the Delaware Bay, and then of course
Basically,
now what we have here.
Basically, I've just given stuff to Walter, just because I felt like he deserved to have it. Like some of the images we're going to share tonight, and he has gone above and beyond to basically model these things, and he really deserves those. He's really, I would say, our third member of the Little Tensas Bayou Experiment. He's done some great work.
My screen back. You can see back where we
left. Presented you.
Yeah. Right. I think I might be finished. I think I might just have 2 more slides. Let's see. Okay, I already did this. I'll move through it and leave it there for that. Okay, I just have 2 more slides. I want to just like make mention of where I'm headed. I'm pretty much if I'm done with flat Earth, but I'm going to move in a direction. I do love geodesy. I think it's very interesting, especially the history of it and where we've come from. And what I plan to do, I'm going to start making videos, and I'm going to use this book attempt at making little videos about this. I'm going to go through this chapter by chapter, what was going on in the 1600s and the 1700s and the 1800s, using the reports, the surveyors, for the historical information on the instruments, the maps and charts they produced, just all the things that interest me. Maybe others might find interesting too, but I'll make these little videos of that. I just enjoy it so much that you can just see arduous things that they went through to climb the mountains that they had to climb, to get the vantage points that they needed to triangulate through Europe, through South America, through India, you name it. I mean, and you know, the way they write about how hard it was for them, and the things were so rough on them. I'm sure there was loss of life. There's no way. I mean, there's one story where they in this mountain and they buy a building from one of the local natives. They dismantle it. They haul it up to the top of the mountain to create an observatory where they put their clock and their huge telescopes. We're talking about long telescopes for doing the astronomical observations for latitude and longitude. And the vertical and horizontal circles are 3 feet in diameter. These are tremendously large instruments. So just a lot of this. It's of interest to me, and maybe others might find it interesting. But that's what I want to do. A little reading of this book and showing, and maybe doing the research to find or other information on what was going on. There's that. And then I'm just going to plug my group here on Facebook, because it's changed a lot over the past year. And it's going to probably just head in the same direction, and this will be where I share the videos that I'll be making about geodesy. And that's it. I'm done with. I can't wait to see what you're going to show us next, Soundly.
Okay, I'm up.
Sharing here.
I would say I'm not done.
That's why I paused.
Let's be honest, you're not done either. Let's be honest.
But I do want to move in a different direction. Let's put it that way.
One of the things that we talked about, that people might be interested in, is that we don't really consider ourselves flat Earth debunkers anymore. We're more globe Earth tourists.
Earth curvature tourists.
Yes, Earth curvature tourists is what we kept referring to ourselves during the weekend. And I totally agree with that, because the reality is we have shown overwhelming evidence time and time again, and the only response to that is that it's fake. And you guys, yeah, and you guys have seen this. It's just like NASA. I mean, we've basically fallen into the same, group as NASA. All of our stuff has to be fake, because if it isn't, then it totally defeats the flat Earth theory. And you guys have seen this stuff, but basically, the day that we did the Marriott observations, the day that Jesse went and did all of his work for the Marriott, I was, again, we're on a different mission. I was taking photographs with my new camera and my new telescope, and it's things that anybody can photograph. This is actually photographed or filmed from the top of the garage, which is part of Lakeway 1. Or actually, it's called 1 Lakeway. So anybody can go here and film this. And this is, I mean, obvious curvature of the causeway. Even back here, you can see curvature starting clear before any type of atmospheric effects or horizon problems or mirroring or whatever the things they like to call.
Soundly, can you tell us how far apart these sheds are?
Sure. These sheds are approximately a mile to a mile 0.2 apart. This right here, this hump back here is called a marine span. It's 8 miles away. And you can see cars coming over the top right here. It's blocked by this hut, but you can see cars coming over the top right here of the marine hump, which is 4 miles away. So that black car right there is 4 miles away. So from here to there is 4 miles. And that's where you're seeing the water line right here in the huts curving. And
again, we're seeing that incredible foreshortening or compression of the image, because it's a zoomed in view. Yes. And again, remember that those sheds are approximately a mile apart. Look at how steep those humps are, especially at the 8 mile mark there. It looks like those cars are sort of getting up at about 45 degrees.
Yeah,
it's just crazy.
And one point I'd like to make, since you brought it up, actually, is that the foreshortening is what's the word I'm looking for? It's something that's produced by the perspective. It's not produced by the camera. And there's this misunderstanding that the camera does this production. No, the camera doesn't do anything. This is what you would see if you had eagle eyes, right? Yep. And if you took if you take a less or a shorter millimeter length lens, right? So a less powerful magnification lens, but you put up a larger sensor on there that can get 42 megapixels, for example, then you can zoom into that and you'd see the same exact image. And that's what people need to realize, is that this is a product of perspective. It's not a product of the camera. And it's there for anybody to see all the time. You just need the right equipment to go look at it. And that's what I've done. I've gone and got the equipment to look at it. So let's move on to some still shots of the same scene. This is actually a 42 megapixel image. So you can get really in there and see what's going on. If you can look right here, you can see huts that are back behind this fender system. That's what these are called. These little things that poke out from the side of the causeway are called the fender. It's a fender system. Basically, just fins off boats. Boats are supposed to go through there, not hit the bridge. Moving on, this is a little bit different angle, and you can clearly see this mirroring effect going on. We can look past the fenders now because we can see these huts back here. That's what I was trying to do with this angle right here, is to see past the fenders. And it would be nice if we could get a little higher, right, Jesse? Is Jesse still there? Is he with us?
I'm here. Can you still hear me?
Yeah, I was like, it would be nice if we could get a little higher to get away from this mirage, wouldn't it?
Yeah, you got any place you could maybe somewhere?
Yeah, So I'm just gonna go through my normal routine. So this is my normal routine. I usually start on top of the garage, go to the top of the levee. I think this is a shot from the top of the levee. And then moving along, this is the east side of the causeway. So now we're looking at the marine hump at 4 miles, marine span at 8 miles here. Curvature is clearly visible all the way back here, like even before the 4 mile. Let me try and get rid of this little thing here. So you can see the water line itself is curving. And then you can actually see in this picture the 12 mile. This is right here is the 12 mile bascule. And it's basically the same type of tower as this at the 12 mile bascule. And it's clearly, you know, down behind the fender system here. Let's move on. This is always a point of contention. There's a little left turn in the northbound lane. Once you get past this left turn, which is at about a mile, all of this right here, clear to the other side of the causeway, is practically straight as an arrow. This is the first crossover.
That's for what, 23 miles straight?
Yes, 23 miles. Yeah. Or 24. It's 24 miles the whole way, but minus this 1 mile, it's 23 miles.
Yeah.
So it's just perfectly straight. And this is the second crossover, which is down in the water. In the very next picture, I'll go up a little higher and take another picture. And there you go. Here's the second crossover. And you can see the fender system now. There's the fender system right there.
Right.
Underneath the second crossover. And moving on, this is underneath the southbound lane. So, you know, the roof itself is actually curving down into the water right here. This is a shadow being cast by the left side. The shadow being cast right here. Here's the shadow curving down. Here's a more. Here's a 42 megapixel image of it. You can zoom in on that. Here's the left side. So here's the west side. And this is the huts from the ground level, basically. This is just right outside the riprap. The riprap is the rocks that are right on the shore. You see curvature. And then, so we were talking about, you know, Walter Bislin. And he has really been an invaluable resource for us. And so he has some stuff that I'm going to have to show you here in a second. This is the Marriott, and this is, like I said, 3 Lake Way and 2 Lake Way being obstructed by the horizon. I've got video of it. This is the fender system right here. And again, let me try and get rid of this little player. There you go. You can see the lights being lit up on the side of the huts, curving straight over the horizon. Marriott's completely obstructed. 3 Lake Way and 2 Lake Way are completely obstructed. And right here, you can see 1 Lake Way, the tip of it, the very top of 1 Lake Way, which is an entire building below the horizon. Moving on, we caught airplanes from the same location that were landing underneath the horizon. By our calculations, they're like 200 feet up still whenever they're going below the horizon right there.
Now this, hey Sally, this would be, Sean had recently hang out with somebody named Cliffhanger who had a program, and there's probably other versions of this that track the flights, and that might be one that you and I were talking about to try to time perfectly when to when it is actually reported to have touched down.
Yeah.
And you know, you're gonna know that that plane is on a trajectory. It doesn't just flop out of the air and drop onto the runway. It's still traveling linearly as it's descending.
That's exactly right.
Some moments later is the real touchdown.
It would be quite good to have a simultaneous view from 2 different elevations, showing the plane still landing while from the first camera is hidden. Now, the question in the chat, what is the black line horizontal?
That is the horizon right there.
Yeah.
Yep. And the black line is it's just the how the light's being reflected. For some reason, the light's not being reflected right there, and a little further down it is. It's not being reflected to us anyway. It's just dark.
Yeah,
Very
and that,
cool to
I
watch
guess,
things dropping, or just landing and disappearing below the water level.
Yeah, it was almost like a sunset because you could actually see the refraction, like holding the light up a little bit longer after it landed. If we
Not landed,
try and get this off the
disappearing.
or after it's like, yeah, after it goes below the horizon, it hasn't landed yet, but it's going below the horizon. You can kind of see it like pulling that light up, just like a sunset. It's holding on to it a little bit longer. And I actually called it in that video. I'm not sure if you heard it or not, but in that video, I called it a plane set.
Plane set.
So Walter Bislin, he created this great tool. Everybody should go check it out. It's got all these different things. One of them is the Causeway. You can adjust your height. Wow. You can adjust your zoom level.
It's amazing.
You can adjust all these different things. The pan, the Nick is whether you're looking up or down. I'm not sure exactly what Nick means, but it must be how he refers to it in his native language. And then there's the roll. But this right here is basically what we would expect to see from the 15th floor of the Marriott. And so my question is for everybody, especially flat earthers, if we went to the 15th floor of the Marriott and we saw this, would that be convincing to you? Because I've asked other flat earthers this and they said no. And my question for them is, what?
They say, okay. They say, where is the curve? And then we show them the curve, and then they say, no.
Where is the curve? Well,
yeah.
Here's the thing,
there's the curve. Okay. There it is. That is the curve. And if anybody wants to argue any longer about this, then I can't say anything other than you're delusional. I mean, you can go to the 15th floor of the Marriott yourself. You can buy the night there, stay in New Orleans,
a little bit extra,
take a vacation,
be on a lake-facing view.
Yes,
but it's worth
a little bit extra. But guess what? You're going to be taking a vacation in New Orleans to do this anyway. It's a great city to go visit. Go visit New Orleans. Go to the 15th floor. Get a lake-facing view with your P900 and take that picture right there.
Hey, splurge!
Like
there it is, guys.
Get a room on the 16th.
Get a pair of binoculars.
Yeah, really splurge.
There it is, guys.
Yep.
There's the curve. So
earlier we were talking.
They asked for the curve. There's the curve. And guess what? It looks just like the model.
Yeah.
Yeah. And we were talking earlier, Soundly, about this. And the fact is that this is a picture of the Earth curving. A concrete structure that is curved. It's level, but people keep forgetting that level is a curved surface. Now, if this is not, then flat earthers should recognize it as a very excellent example of whatever this is.
Of
if they want to say that the Earth is flat, then look at this picture and look at other pictures around the world that clearly the Earth curving. But if you're going to say it's not, then you have to explain and give us the science to it, give us the measurements, give us the predicted ability to make a model of that. This flat Earth science and flat Earth mathematics, give it to us.
Give us some flat Earth geometry-based model that looks like this. That's it. It's very simple. Flat Earth geometry-based model that does this. And then we can take these observations and match it to that model.
There you are.
That's all we asked for.
I'd become a flat earther if
you get to see it.
Now, something I'd like to point out too is that if you look at this picture on screen and look at the areas of the lake either side of the bridge, especially on the right-hand side there looking towards the the land on the other side, is that on the water you've got no point of reference to look for curvature. But here we've got this unique situation with the Lake Pontchartrain Bridge, where we actually have a reference, being the bridge structure itself. If you don't have that point of reference, you cannot see the curve. All you see is water.
Right.
So yeah, this is a fantastic opportunity.
And the thing I'd like to point out too is you can look at the water line itself, right here, the bottom of the bridge, and that water line is curving. You know, you can't argue with the water line. You know, they might want to argue about the bridge being built this way to convince everybody, but you can't argue with the water line.
Yeah.
Okay? Here's the water line right there, and it's clearly curving.
Soundly, this looks like the same image that I did an analysis on. Is that correct?
Yeah, this is the same image, yes. Okay. Do you have that image?
No, but if you just pull up that enhanced one, or is that the same one, is it? That's the video, okay.
This is the same angle, but this is video.
Yeah, what I wanted to point out was that looking at the sheds, the one that is on the far right-hand side, against the edge of the frame there, that is shed number 2 as from the side of the lake. So there is another shed which is just out of view, okay? And so, yeah, if you just leave it on that one.
This is shed number 2 here, right?
Shed number 2, which is on the far right there against the edge of the frame.
Yeah, this one, yeah.
Shed number 2, shed number 3, 4, so on out the other side. So looking at this whole picture, I worked out the angles using Google Earth from our vantage point. And the field of view that we're looking at, and first of all, I'll make the point that the flat earthers often say, well, you know, you're supposedly showing us ships disappearing over the horizon, being hidden by the curvature of the earth. So why can't we see the curvature horizontally in that image? Well, the reason being, as we've already pointed out, we're actually compressing 24 miles of bridge into this image. So we're looking out away from us 24 miles, but the actual distance that we're looking along the horizon is only a very short distance. And the angle of the field of view that we're looking at in this image, I've calculated to be at about 0.8 of 1 degree. So yeah, so I haven't, one thing that I failed to do was to actually measure, and I could have done this very easily, to actually measure the amount of the waterfront or the shoreline along the other side of the lake across that 0.8 of a degree field of view. The other thing I'd like to point out, and I had to ask you what this object was, if you can point it out, please. There is this strange sphere. Some of my viewers might think it's Nibiru on the horizon, but that's actually a water tower. And can you remember how far away that water tower is?
I don't remember it actually. No, I don't know.
Mm-hmm. Well, I saw that water tower when we drove north to the north side, and it's not far. And I'm going to guesstimate if the causeway is 24 miles, it's in that neighborhood. Just like when you get onto the other side, neighborhood, that water tower is up in that neighborhood. So maybe it's another mile or not much more than that.
Yeah. Well, my point with the water tower is that it is actually further away than the end of the bridge. Obviously, it's over on the other side. What is the location called?
The Mandeville.
Mandeville. So this water tower is in Mandeville. It is past the end of the bridge because it is part of the Mandeville township.
Yes.
So it's further away than the end of the bridge. Yet we see the end of the bridge, which is 24 miles away. And what is the observing height of this camera here? This is from the 15th floor of the Marriott, isn't it?
So 150 feet about.
Right. So, well, this is interesting because from the 15th floor of the Marriott, we can see the end of the bridge curving down and over the horizon. We can see those sheds curving down over the horizon there. Yet we can still see the water tower in the distance because, of course, it is up higher.
Right.
Yeah.
The other thing I'd like to point out, Des, is that this water tower kind of gives you a sense of scale as far as this distance right here.
Yeah,
Because
that's right.
you know, this isn't a mile. It's a couple hundred feet, and so you know, just stack that out, and you can figure out exactly what type of distance you're looking at there, or at least get a feel for it.
Yep.
And like you said,
I might try and pull up my Google Earth because I've got these locations saved, so hopefully that won't foul me up.
So that's the video, and actually I had another. Yeah, so this actually, I think this image might be actually a little better for analysis because you can see more stuff over here on this side. This right here, it's very hard to see in this image, but you can see this vertical line right here.
That's the windmill.
That's right. There's a windmill on the right next to where we were doing our photography.
Right. In fact, the concrete pad that we're standing on for that windmill.
Right. The concrete pad is like, well, wait, it's the foundation for the windmill?
Yeah.
The windmill's on that pad? I thought it was a little bit more to the left. Maybe it is that windmill. You could be right. Can't remember now.
Yeah, no, the that's what we're standing on.
So this is what we're standing on right here.
Yeah, we're at the foot.
So we're actually below the horizon in this picture. Yeah. It gives you a sense of like just, you can actually go look at what we were looking at in or where we were standing in Google Earth, and you can find this little windmill, and you can find the edge of the causeway, and it'll show you, just how much distance this is, which is very little distance right there, left to right. Whereas we're looking at 24 miles here.
I'm actually glad that.
What's that?
I'm glad about the side-to-side inability to see curvature side to side because of the fact that we're only looking at maybe 2 at most, but probably not. But what we are seeing is much further out. You're not going to see that clown frown, side to side. You're not going to see that.
That's right.
Yeah. But this
does anybody have anything else to add?
Okay,
anything else to add? I think that
the measurement from the motel to the water tower is 25.9 miles.
I'm going to say 25.
Yeah, 25.9.
26.
Yeah, 26. So yeah, it's almost two miles further on. And also talking about the scale of the water tower itself, I also measured that. Let me just check that. And it was really hard to measure because using satellite imagery and the angle and so on. I did compare it from different historical views from the satellite, and it's around about 65 feet in diameter, give or take maybe 5 feet either way. Okay,
that's interesting.
And
so 65 feet right there, and now compare that to this whole distance right here. It's not very large compared to this distance right here, which is 24 miles basically. 23 miles maybe. So
I think we're at the hour-and-a-half mark.
Yeah, so this is like 2.8 miles to the right edge of the frame out from the shore. So this is right here. It's 2.8, and over there is 24. So that gives you an idea of what we're looking at. Yeah, so hour-and-a-half mark. We've gone past our desired time frame, but I hope it was worth it, and I'm glad everybody stuck around for it. Seems like we still have a lot of people watching. So thank you guys for coming and watching, and we will see you guys another day.
Sounds good.
Thanks, everyone.
Bye-bye.
thank you. Good night.
Thanks, Des. Thanks, Alan. Bye.
If I can figure out how to turn it off.
Is it